Chain rule capstone. I think what they're talking about when they say capstone is we're putting it all together. So all the ideas that we've been dealing with, trigonometry, exponential functions, e to the x, natural log, log, all of those are fair game with the idea of the chain rule being applied here. All right, so when we look at this, we would look at the outermost function, and when we look at the outermost function, we would see the natural log function. What's the derivative of the natural log function? That is equal to 1 over x. So this right here, the derivative of just the natural log is 1 over x, but we have all of this inside of the natural log. So that means that all of this part will be what we see inside the x part. So that would be 1 over 3 plus x minus x cubed. Now that's just the first layer of the onion that got peeled away. So then it's times, then we would look at the innermost function, that's this function here, that derivative. What is this derivative? Well, the derivative of 3 is 0, the derivative of x is 1, and the derivative of negative x cubed is negative 3x squared. All right, and then usually when we have a number times a fraction, it would just go to the top of the fraction. So this would be equal to 1 minus 3x squared over 3 plus x minus x cubed. All right. There, is that it? Let's see. 1 minus 3x squared over 3 plus x minus x cubed. Yep, there we go. Okay. Let's check out the next one. All right, so when we look at this, first we have to convert it into the radical into an exponent. So that'd be x squared minus 2x plus 8. All right, a cube root. This tells you what the denominator is of your exponential fraction. So the denominator will be 3. So this is to the 1/3 power. The 1/3 power means cube root. So I would do the derivative of the outside, which would be 1/3 x squared minus 2x plus 8. We rewrite the inside of the function. And then 1/3 minus 1 leaves negative 2/3 left. Times, so now I've taken care of this outside function, and now I'm looking at the derivative of the inside function. The derivative of the inside function would be 2x minus 2. All right, and there's not really much simplifying we can, we're plugging in the number 2 here. So we can, and we wouldn't want to have a negative exponent anyway. So let's see, I think at this stage, I would rather just plug it in, plug the 2 in here, and then I can take care of any of the exponential negatives and stuff like that to simplify. So let's go ahead and do that. So this would be f prime of 2 now, would be 1 over 3, and instead of x, I put a 2, minus 2 times 2, plus 8. All of this gets, I don't know, raised was the right word, but to the 2/3 power, times 2 times 2, x is 2, minus 2. All right, let's go ahead and keep simplifying. Equals, order of operations now. 2 squared is 4. Negative 2 times 2 is negative 4, plus 8. All of this is to the negative 2/3 power. Times 2 times 2 is 4, minus 2. Okay. Let's go ahead and bring it over here. I still got my 1/3 power, or it's 1/3 in front. 4 minus 4 goes away, so I still have 8 to the negative 2/3 times 4 minus 2 is 2. Okay, so I'm going to go ahead and move the 2 out front, so that becomes 2/3. Negative exponent puts it on the bottom, and so this 8 is going to go on the bottom, and then I'm going to break apart this exponent, this fractional exponent, into the pieces that work the best. So I have an option. Should I square it first, or should I do a cube root first? Always do the root first if it goes into it evenly. So does 8 have a cube root? If it doesn't, I would probably square it first. But 8 does have a cube root. 2 times 2 times 2 is 8. So I'm going to go ahead and rewrite this. It throws it on the bottom. And I'm going to do the cube root first. So cube root of 8, and then I'm going to square it. So that's the same thing as negative 2/3 power. It flips it on the bottom, and then I have the option of squaring it first or cube rooting it first. Since this 8 has a cube root, I'm going to go ahead and do that first. So all of that turns into 2 is on the top, 3 times, that's going to be 2 squared, equals 2 over 3 times 4. And I can reduce it or multiply it. I'll go ahead and just multiply it out. That's 12 and 1 over 6. Okay. All right, so just going through the steps here. First, we have to rewrite the radical in terms of fractional exponents so we can use the power rule on it. When we apply the power rule, we take the derivative of the outside first and rewrite the center, times the derivative of the next component, which is unpeeling the onion. We're lucky that we don't have more than 2 functions here, so maybe we'll see that later. So then times the derivative of the inside, which is this component here. Then we see that we're doing plugging in a value, which means that it's easier to plug it in as soon as possible, so we don't have to worry about all the algebra of keeping the x's. So I went ahead and I plugged that in, order of operations to simplify. All right, looks like we got a trig function here. That means we're plugging it in after we do the derivative, so let's go ahead and give that a shot. So the derivative of sine is cosine. Rewrite the inside. Times the derivative of the inside. Now, pi over 3 is just a constant, or negative pi over 3, so that drops off. So we would just be looking at the derivative of 2x, which is just 2. Okay. Now we're going to go ahead and plug in our pi. So x is pi, so we'll go ahead and just plug it in right there. That's the only x we see. So this turns into the cosine of 2 pi minus pi over 3. And let's go ahead and move that 2 out in front. All right. Oh, our friend trigonometry. All right, so when I think about my unit circle, basically, so 2 pi says I go around it 2 pi times. So I go around, I start over at the beginning, and then I'm going to go minus pi over 3. So minus pi over 3 means I'm going the other direction. So usually we would go counterclockwise. This reverses it, so I'd go clockwise. So I'm going to go this way, pi over 3. All right, so that would be a pi over 3 right there. And we're in quadrant 4. Okay, so we would look at this in terms of a reference angle. Pi over 3, I like thinking about it. I have all my special triangles memorized. We can replace pi with 180 or use a converter, either way. Turns it into 60 degrees, right? So this is 60 degrees that we're looking at. And we're looking at cosine of 60 degrees, and then remember that we're in quadrant 4 here. Okay, so special right triangle. This is 60, this is 30, this is 1, 2, radical 3. Okay, so, and I'm looking at it in terms of this one, so, but it doesn't matter, I'm just reorientating it. And we're looking at cosine in this case. Cosine, so ka toa is adjacent over hypotenuse. So adjacent side to the 60 is a 1. The hypotenuse is a 2. And cosine, so if I think about tangent, which is sine over cosine, which is equal to y over x, that means cosine corresponds to the x value. Okay, so is x negative or positive in quadrant 4? X is positive. So that means 1/2 is our final answer as a positive answer. Okay. Oh, what happened? Let's see. Uh, darn it. So do you know my mistake? I was so quick to kind of move on from the trig. So what I did is I found cosine of 2 pi minus pi over 3. So what's my mistake? Darn it. So all of this turned into 1/2. I still have my times 2 in front. 2 over 2. Uno. Well, that's what I get for trying to go too fast. There I go. Keep up the great persistence. Thank you, Professor Kahn. All the trig was correct. I forgot to multiply by 2. All right, and this one looks similar to what we just saw. This is our base to the exponent. That's an exponential function. So we're going to use, I've come this far, I might as well finish it. So for this one, I would keep rewriting this just to practice it. D dx of a to the x. Let's see if I can do it from memory. I think it is the natural log of a times a to the x. And then I'll check my notes. Natural log of a times a to the x. Yep. So that means when I do this, the derivative of the outermost function, the derivative of the exponential function, is going to be the natural log of a. A is the base, times, I'm just going to rewrite all of this, times, now I've done the outermost function, then I look at the innermost function. The derivative of the innermost function is 12x minus 1. And then that needs to be in parentheses. All right. Natural log of 5, 12. Just be careful. I don't want to jump. All right. That looks like it. All right. I missed one. Going too fast. All right. So hopefully this kind of gives you a good idea about how to approach these. Keep on practicing. Better luck next time. I would do this again just to get that perfect.